Hi everyone. Just a quick pre-recorded lecture to replace the lecture we would have had in week 9, but also to go over some of the points that we discussed with your studio reps on Friday. So the main thing we discussed in the studio rep meeting was the data visualization model, which we've just spent the weekend reading through all of your abstracts, and we're really thoroughly impressed, especially given the circumstances that you've all put together a really thoughtful approach to, as opposed to your site and your design, but the way you're sort of abstracting and thinking about the information coming from that. That was really encouraging to us. Cool. I'm just going to go over a few things that came up in that meeting with the student reps on Friday that hopefully will answer a few of the questions we're all having and will get us heading in the right direction with the data visualization model assessment for assessment 3. So on that, the assessment, it's worth 10%. We'll provide a rubric next week that sort of sets out how the marking criteria will be done. It's due on May the 4th, the same day as assessment 3. And what it is a digital model. So that's either an STL, an OBJ, or some other digital file that translates individual research into a 3D digital form that represents the relationship between different data sets and the site. This isn't a separate thing to your studio work. It's sort of an extension. It's you distilling all the information from your studio into something that's presented as a 3D form. So we had a few questions about what is a data visualization model. So as I mentioned, it's a model that distills the important elements of your research. So it's different for everyone. But essentially what we want it to be is a tool that you can use to take all of the research you've been doing. You're spending weeks, almost months now, researching these really individual niche topics. And this is a way for you to take it, abstract, and turn it into something visual, digital, that has a 3D form, so you can explain all this complex research you've done quite simply, and the relationship that has to the spatial qualities of your site, but also other data that you might have learned. So an example that I gave on Friday is you might be modeling density versus building material. So you might do a model that says the very base model is density, right? So in the city, there are areas of different density. But for your model, especially for someone like you might be doing high performance, might be looking at this, it's the way density changes when you're talking about the building materials. How many timber buildings have super high density as opposed to steel or concrete buildings? So that is a way of sort of relating two sets of data. And then it starts to tell a story about the existing conditions, and you can make predictions about the future based off that. So yeah, you're all researching different topics, so it's going to be completely unique to all of you. But it's a tool that simplifies your extensive research into a 3D model. I've already said it, but this is not separate to your research and design proposal. The data is a summation of the information you found, and it signals the direction you want to take it. So essentially what you're using it for is you're going to do crits in front of not only your tutors, but guest crits. They're going to come in and they're not going to know all the research you've spent weeks slaving over. They're not going to set in on all the meetings. They're going to have to sort of take your word on a lot of the data. But when you have a model or something visual, something in 3D, you can show them that represents that information. It's so much easier for them to understand the way it all comes together on your site. So it's a summation. It makes it clear what your design research was, what your design direction is. You can model it and say, well, I've modeled the data in such a way that I can understand there's a problem in this area of the site that can be solved this way. That then becomes a justification for your design direction. We also had a few questions about could we get some really basic examples of data visualization models just to kind of spur you on so you can see a benchmark. So we talked a lot about benchmarks in the meeting. So I've got 4 examples here. They're not particularly special, but they just sort of show you the different ways you can visualize data. And most of these have been taken from the Data Fizz website that's featured in the module lessons. This one is the Very Pointy Elevation Map by Data Appeal. And what it is a map of all the transport hubs, and the height of the spike represents how many people access the transport links through that area. You can see there are two major spikes, and they represent the two biggest train stations in Toronto. You see all the smaller ones, and you see some larger ones. And you could then use this data to talk about density against public transport. You could plan out future public transport based on where you think density is going to be put. So it not only becomes a way of expressing the information from the site, but it gives you something to comment on and work against when you're designing. The next one is behavioral landscapes. This was done by Studio Lab at Pennsylvania State University. This is a far more complicated idea. What they're mapping is emotions. So there's a really complicated paper on it, which I'll share with anyone who's interested, that shows their framework for mapping emotion and mapping personality changes over time. But essentially they come up with a framework and they model it in a program pretty similar to Rhino, using a tool that you could do with the Drake tool in Rhino. And then instead of trying to overlay it, make it complicated, they put together 9 blocks that represent different emotional states. After reading through quite a lot of your abstracts, something a lot of you were talking about were social interaction, so loneliness, isolation, that sort of thing. This could be ways of mapping that. So mapping the way different mental conditions affect people differently over time. So there is a way of sort of, it doesn't necessarily need to all come together. They can be standalone models. This is the US unemployment rate from 1948 to 2015 by John Keegan. So he was a journalist for the Washington Street Journal, Wall Street Journal rather. And so he came across this data map that was published in the Wall Street Journal when he was working there. And then he transitioned to not only being a journalist, but a data visualization journalist. So he took that data, extruded it out 60 odd more years, and then he modeled it as a 3D form. And you can see as a form, it's not particularly interesting, but what it does do that you can't do with the graph is you can pick it up and you can see the different heights, you can see the different conditions. He's uploaded this to Thingiverse, which is the way you'll all be presenting your assignment. So that's just the way he's presented it, and we'll talk more about Thingiverse next week. And finally, this is 4 models of the taxi density in Barcelona by, I don't know if I'll pronounce it right, but Fodos Basha Gils. This is, again, kind of a bizarre model, kind of a bizarre map. But why we included this one, because it shows you some really different ways of doing it. So one of them is cylinders, sort of mapped up to show height, to show popularity. The other one is the shadow cast, that is representing the popularity of the taxi rank. So that's where people take taxis from. They also use bubbles, they use a heat map, because there's a whole range of things. And what they did in this one is, this is a university course in Spain, I think. They have to map the same condition in multiple ways. So why create data visualization models? We have 3 reasons. The first one is, as I've already discussed, it distills the crazy amount of research you guys have done into something that's concise and explains your understanding and position. And by position, we mean that whilst you're all doing research, and a lot of you will be researching similar things, because you're all unique and you approach this from different backgrounds and different experiences, you might take a slightly different position on what certain density relationships mean. You might see it as positive or negative. You might see the way it relates to transport as a good thing, or you might see it as a way of creating more noise pollution. There's always sort of a way for you to bring your own personality into the design, but also these models, the way you put them together is going to show that. presenting information in different medium forces you to consider that data differently. What we mean by that is you guys have been reading and writing and researching and doing little maps for a long time, and you can get stuck in that process. What this is a way of pulling you out of that, making you produce something completely different using that same information. And that does two things as far as we're concerned. It makes sure you know what you're talking about, because if you don't, when you go to translate into something physical, you're gonna have a lot of problems. And it also gives you a lens to reconsider it. So if you've been reading the same thing, looking at it flat on a page, then you can sometimes miss something. It's the same as if you've written an essay and you kind of go and keep doing drafts, but you miss sort of obvious spelling mistakes that someone who hasn't read it before comes and picks up. This is the same thing here, where you're looking at it a different way, and you're looking for then things you might have missed, different patterns. And the translation of information to form, either physical or digital, is an essential skill for architects and designers. We really think this is important, the idea that you can take information and then create something physical out of it, or digital out of it, something that is form, is a lot of what we do, even if it's a brief to an initial concept sketch to an initial massing model. There's always that relationship. So it's about being able to abstract information into something that has form. I thought this was a nice quote, so I'd include it. I try to give people a different way of looking at their surroundings. That's art to me. So this is by Maya Lin, who a lot of you will know, hopefully. Did the Vietnam War Memorial, which she won as a competition when she was still an undergraduate student at Yale. She sort of sits in that junction between art and architecture. A lot of her work is probably more sculpture than building, but I included her partially because I love this quote, but also because a lot of her work focuses on the role of data and the way it can influence a form. So the image in the top right is at Yale. It's called the Yale Women's Table, and it's a table carved out of marble that represents the difference between men and women as undergraduate class intake at Yale from 17 or something to 1992, when they finally reached parity. So as a sculpture, it's quite beautiful, but there's also a story, and sort of that gives it a reverence, that there's a reason and a narrative behind it. So we want you to think a little bit like that. In what way can you use this data you're finding to represent something beautiful? So what are the deliverables? And then what else you can submit? This came up because a lot of your data abstracts reference, you ask, can you also submit this? Can you do this? And we're happy for you to work with you on a lot of different things, but we're going to set out the absolute base deliverables and then the other things you can do. So the absolute base is a 3D digital model, an STL, OBJ, KMZ file if you're so inclined, that maps the relationship between data, so two or more sets of data, and the site, if you choose, and then a brief blurb explaining the model. And this is all going to be uploaded remotely to Thingiverse. Thingiverse is the website that I mentioned that John Keegan had posted his unemployment model on. We'll provide a guide on how to submit to the Thingiverse. The reason we're going to submit to Thingiverse is it's a great platform for sharing STLs. It's a good thing to sort of make you aware of, but it also lets you upload a whole lot of additional information if you want, which kind of ties into this next part, the optional that a lot of you talked about. So a lot of you asked if you can submit images, graphs that highlight the data in 2D. Definitely, we encourage it. We think it sort of gives a more context to your model, and also, as I've mentioned before, this model isn't separate. It's part of your studio submission. So it should be a distillation of all your research that then sort of surmises where you are and sort of gives a glimpse into your direction. So whilst I think all the graphs you submit in your studio book, you should submit um, in conjunction with the 3D model if you think it would help. I think it could also help in your studio submission in your booklet to submit an image of the 3D model with sort of an annotation about what it meant and how it came together. Can you do GIFs and animation? And I think definitely, again, this is something that I think could really benefit if you want to show the way things have changed. A lot of you are talking about modeling past, current, and future conditions, especially for things like density. And you wanted to make a model that changed to represent every 10-year increment or things like that. And I think a GIF or an animation is a great way to do it. One that came up a bit, and I'm quite interested in, especially if people want to work with, is interactive submissions. So that's something that the user can operate. So instead of just being a GIF that changes automatically or a video that plays and stops, or it's a screen where there's a series of push buttons where you can sort of select your parameters and it will change automatically. Like I said, I'm kind of happy for you to do this. It is more difficult, and there's a few different ways to do it. So there's a really simple way that I'll put a video up for next week. And then there's a few more complex ways involving some pretty basic coding, but it requires some sort of beforehand knowledge, but we can still go into that if anyone's really interested. And also physical models. If you have a 3D printer or a CNC or a laser cutter, or you want to physically make your model using analog techniques, you're welcome to do that. We're not going to mark you on a physical model, but if you think it sort of adds to the process or it helps you think, or I know when I'm designing, I always like to make, just sort of gets me away from a lot of the drawing and the research, but it's also a great tool for communicating. Okay, so next week, we're going to set up some remote consultation sessions where we can discuss the data visualization model one-on-one with you. And we'll schedule that during this week, and we'll sort of let you know how to book it. And then we'll also put up some technology tutorials that are based on the questions you had in your abstract. And in the meantime, if you have any questions, please email us. Our emails are on Moodle, because we're really keen to work with you guys to make sure you get the best out of this. Awesome. Thanks for listening. Have a good rest of the studio day. Cheers.